everybody. My name is Milne.
I'm Daniela, Oliva.
I'm Daniela.
We're Team 16, and our project for Mechanical Design 2 was a gearbox speed reducing system. So the problem statement was given by a professor, was our assignment to transmit a horsepower of 4.5 specifically safely throughout our system. Apart from that, the speed had to be reduced from a given input to a given output to a system of gears. And another objective was to learn the use of commercially available machine element catalogs and their parts and how to select them. For a project are first of all to design the gear system that the professor assigned us within the given constraints. These constraints were for it to transmit a minimum horsepower safely throughout the entire system. Also, the input and output direction of rotation of our shafts was opposite, and the orientation of the shafts were perpendicular and on the same plane. Another objective of our project was to learn the use of commercially available machine element catalogs. This way it's a practice for the future work when we have to select gears in our real company project. And lastly, our objective was to learn how to work in a team and divide tasks and bring a product together as a team. For our project, we only had one design alternative, which was our first approach. Initially, we picked gears just at random to follow the speed reduction that we wanted to get without taking into account other factors like bending and wear. Consequently, when we did the calculations for wear, we had a failure of our parts, so we had to go back and do the selection procedure more appropriately. We realized that we had to stick to the ratios that were made by the catalog, which paired the gears in with their appropriate mates. And after this, we were able to calculate everything safely.
The structure of our design was very simple. Since we had two perpendicular shafts that spun in opposite directions, we needed to include an odd number of gears, as you can see. So to begin, we started off with a small pinion and we stepped up in the pitch diameter throughout the system. We had 3 spur gears to create the rotation of the speed in the direction that we wanted, followed by a final 2 bevel gears to create the perpendicular motion that we wanted. The housing that we created was basically a very simple system in where we had 2 holes on each side of the housing to hold bearings, which were attached to the shafts, which were the gears were mounted on. The gears were fixed onto the shaft, and the shafts go through the bearings, which were fixed onto the housing. As you can see, there's 2 holes for each gear, 1, 2, and 3, followed by a final 2 holes for the gear 5 in that direction. The application of our system was basically a transmission system that you could attach a small motor to that transmitted 4.5 horsepower and at a speed of 2,090 RPM. And we wanted a reduction of speed for the purpose of using the machine as a practicing tool for goalies. Whenever a goalie wants to practice in the field, we want them to be able to have a machine in which would kick soccer balls to them and that they could use to block the system. So in that respect, we were able to achieve a final rotational speed using SolidWorks simulation of 116 horsepower at the prosthetic leg, which you can see, which rotates in counterclockwise direction in order to kick the soccer balls with 4.5 horsepower towards the goal. Daniela will now speak about the results of our application.
So the catalog that we use to select our gears for gear system is the Boston catalog. In order to determine if the gears that we're selecting are safe, we use the lowest method that came with the Boston catalog, and then to validate our results, we use the AGMA method, which has equations for spur gear bending, helical straight bevel gear bending, and also it gave us equations for wear.
You can see that we met all the design objectives presented by the teacher effectively. By comparing the results that we obtained from the Lewis formula as well as the AGMA calculations, we were able to validate the selection of our gears. As we saw before, all the horsepower ratings were above the minimum prescribed by the professor. Another objective that was met was the learning of use of commercial catalogs. This way, we learn how to apply the knowledge that we learn in class to real-world procedures and selection procedures. And finally, this project was also a good exercise in building teamwork experience. We spent lots of hours in divided tasks and then got together to bring a final product.